Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And today what we're going to do is we're going to build upon the synthesizer framework that we built in the last tutorial. And we're going to actually get sounds coming out of our synthesizer this time around, as well as adding a component or two, such as an envelope or possibly a filter, so we can get some more control over our sound and start making this thing actually sound like a real synthesizer. For this, we're going to use the Maximilian sound library. And the reason that I'm doing it this way is because I think it's easier for us to start out at a higher level and to use components that are already kind of built for us so that we can just take those and we can place them in the right places and really concentrate on getting the code for the synthesizer itself right. And then if we need to, we can actually go lower level, and if we wanted to build our custom oscillator or custom filter, that we could do those things as a little bit more in the future. But also, the Maximilian sound library is an excellent library that is very useful, and it's a very high quality library. It's been used in a number of commercial applications. So that's what we're going to use today. So first thing, let me show you the Maximilian sound library. I went over this a couple of tutorials back, I think 2 or 3 tutorials back, so I'm not going to spend a lot of time on it. But this is where you would get it, and I'll put the link to it below. So the first thing that we need to do is we just need to bring the library into Juce. So to do that, I'm just going to drag this into my header search paths, and then we also need to drag it into our source window here. Okay, and this is something that I've gone through before, just in case you're wondering where I've gotten this from. So check like I think it's like 2 tutorials back that I did this. So we have that imported now. So let's just go ahead and launch, make sure that this is going okay. And then what I've done is I've included it as a header in my synth voice file here. So we got maximilian.h. I'm just going to build that quick. This is probably going to take a second to build. So while it's building, I should let you know about the discussion group that we have on Telegram. So I'll go ahead and link you to that group below. And what we do is we have it's just a little discussion group where we have different developers from all over the world that kind of connect, share ideas. We have all different experience levels. Some people have been doing it a very long time, and some people are just starting out, and so we just try to help each other out and connect. And I hope to see you there. So okay, so it's built successfully. So we know that the Maximilian sound library is successfully imported. So first thing that we're going to do is we're going to go to this function render next block. So just to refresh you on what's going on here, so we have render next block, which we have in our synth voice class, and then we're calling render next block within our within our process block. We have mysynth.render next block. Okay, so this is where we're going to have our audio callback function. So what we can do is we can just start in here. Now, I looked at a couple different examples of how other people have done this, and they've used a for loop, and it's in a different kind of way than what I'm used to doing it. So what I'm going to do, just to kind of make it easier and just kind of standardize the way that I do things here, I'm just going to do it the way that I kind of normally do it. And then if anybody has any suggestions on why it's better to do it a different way, I would love to hear them in the comments or just message me. Okay, so this time we're going to start off with the sample. So we're just going to start with a for loop. So int sample equals 0, sample is less than, and then this time we're going to use our argument for our function here, num samples. Okay, and then we're going to do plus plus sample. So this is nothing different from what we've done in past tutorials here. Then we're going to have a channel. We're going to iterate through the channels. Channel equals 0. Channel is less than. We can just access the channel numbers by doing output buffer get num channels, I believe. My autocomplete just never wants to work when I'm doing these tutorials. It's crazy. Okay, plus channel. Okay, and then we have, and then we could do this. We could also add this as well. So we got output buffer, add sample, and then our destination channel is going to be the channel that we're iterating through. And then the destination sample is actually start sample, so the start of our sample. And then we can go back to float value to add, because that's going to be where we're going to actually calculate the signal that we're going to actually put into the speakers. Okay, and then we need, so we're just going to do plus start sample. Okay, outside of that channel for loop there. Okay, so we have our audio callback here. Shall we just test out real quick? I think this should work. If I do a double, I'll just call this the wave equals, oh yeah, I need to create an oscillator. Great. Okay, so if we just go down into our private variable declarations here, what I can do is I can do maxi osc. Okay, so this is how we create an oscillator. And then I'll call that OSC1. Okay, and then we should be able to say OSC1.sine wave. Sorry that my autocomplete isn't functioning right now. And then what we can do is we can just go down here to our output buffer and just put the wave here. And I think this should work. Okay, what's it saying? I think it'll be fine if I build it here. Okay, so I believe what'll happen is that when I hook this synthesizer up, should just be playing a sine wave, I think. Okay. Okay, not quite. Okay, what have I done wrong? Oh, this needs to be inside here. Okay, I believe. Okay, so let's just try this again. I want to make sure my do I have the sound routed correctly? Sorry about this. Just going to put it through here. Sorry about this. Okay, so now we could just go back here. Let's just try it again. Okay. Great. Cool. So we see that we're getting sound coming out correctly through our audio callback, and so that's a great start for us. So now what we need to do is we need to get some control over that sound using start note and stop note. So the way that we can start this out is we could start by thinking, okay, so we have this code here where we have level equals velocity. Velocity is just a floating point value between 0 and 1 that's going to be instantiated when I press the key on my MIDI controller that I have hooked up. And then when we release the key, we have this function stop note where velocity equals 0. So what that means for the time being is that when I release the key, the sound is just going to immediately stop. Okay, so I should be able to just say times level here. Okay, so we have this variable level that I set up last time. Level equals the velocity, and then when I stop the note, velocity equals 0. I could just put level equals 0 maybe. Level equals 0 because I'm multiplying this by level. So when I release the key, it should immediately stop because I'm just multiplying the sine wave times a value, either something between 0 and 1, or if I'm multiplying it by 0, it's just going to be 0. So let's just go ahead and give that a try. And then here we go. We're just going to add this, connect up here. Okay, now I'm just going to press a note on my keyboard. And as you can hear, we're getting sound out. And you can hear that there are clicks at the beginning and at the end. So it might be useful for us to add an envelope now to get better control over the sound. Okay, so what we could do is we could go down here, we can go Maxi Env, okay, envelope 1. And by the way, I guess I should show this to you just in case you're wondering where I'm getting these functions from, like Maxi Osc, Maxi Env. Okay, if you go into Maximilian, and then I go into Maximilian.h, okay, you can see I just happen to be on Maxi Env right now. Okay, and you can see the classes here. They're actually quite straightforward to read through. So then you can see the implementation in the Maximilian.cpp file. So if I go here to Osc, so Maxi Osc, just to give you a demonstration of some of the capabilities here. So if I go to Maxi Osc here, you can see that we got white noise that we can just throw in there. We've got sine wave. Okay, and you can see that these are just wave tables. Okay, so they're quite efficient. Okay, just kind of standard wavetable stuff. Okay, we got cosine wave, got phasor, got square wave, pulse wave, saw wave, sawn, rectangle, triangle. So there's a lot of different options there. It's really good to get started with, rather than just trying to compute the wavetables yourself. You know, just might as well throw in the sound library and have it do it for you. That's what they're there for. So great. Okay, so this is cool. So we now just need to put this maxi envelope, and we need to work out how we're going to do this. So what we need to do is we have this function called trigger, okay, which is the envelope trigger, because it needs to know, the envelope needs to know when it's actually going to be instantiated, when it's going to be triggered. Okay, so what I can just say here is envelope 1.trigger equals 1. Okay, so what we've got here is we've got just kind of a 0 or a 1 value, just to let you know whether the envelope is being triggered or not. Okay, so when we start the note, we want the ADSR, or the envelope, to actually trigger. So that's why we're putting envelope 1.trigger equals 1 here. Pardon me. And then what we need to do is we need to put envelope 1.trigger equals 0 when the note stops. So when we release it, we need to let it know that we're releasing the note. Okay. What we're going to do here is we're going to get rid of this level equals 0. Okay. There's a function in here called clear current note that I'm going to put in here. Okay, so this is just going to let it know that when our velocity is 0, what we could do is we could just clear that current note out. And what that allows, so if we have 5 voices, let's just say we had 3 voices, and that we were pressing on all 3 keys at the same time, and then we let one of the keys go. Once that velocity gets to 0, then we want to be able to use that voice again for the next key that we're going to press. Okay, I hope that makes sense. So what I'm going to do is I'm going to use this Boolean from this stop note allow tail off. Okay, and what this does is it basically says whether it's going to immediately, whether the velocity is going to immediately stop, or if we're going to allow a tail off at the end. Okay, and this is all stuff that I've researched through the Juce API. Okay, so this is stuff that I've spent quite a bit of time really looking through and just experimenting, trying to find the best way for these, for the code to happen, and the things that work, things that don't work, things that nearly blew my ears out. And this is where you would find all of that. Okay, I'm in synth sound. I actually want synthesizer voice. Okay, so if we just go in here quick, just have a look. Where is it? So if we say stop note, okay, then you can see that there's quite a good explanation here that shows what happens with when it comes to the tail off and what happens. Okay, so I'll let you go ahead and read that, if you get a chance. So that's the reason why I'm going to say allow tail off equals true. Okay, and then I'm going to add an if statement here. I don't know if this is really the best way to do this, but I thought that this would be the best way. So if I say if velocity equals 0, then what I could do, I could just tab in here rather than having to. So if the velocity, so if we don't have any more velocity on that particular note, then what we could do is we could actually just take that note and we can allocate it to the next key that we're going to press. Okay, and I think that's everything there. Okay, what I'm going to do here as well is I'm going to set some arguments for the envelope itself. Okay, just so what we could do is we can start like kind of changing the sound a little bit to make sure that the envelope is actually working. Okay, so you have some functions in here. I'll go ahead and I'll show you quick. If we go into the Maximilian library here, and then if I go to maxi-env, okay, this will hopefully be helpful to some of you if you're not quite sure where to search or how to like find out what functions are available or what sort of things are available. Okay, then this is normally my go-to to go in there and to just kind of search for it. Okay, so you have a couple different ways that you can instantiate the ADSR, attack, decay, sustain, release. I'm going to assume you know what that is. Okay, I'm going to use this one double input. So we're just going to input our sound here. We're going to put whether the envelope is triggering or not. Okay, and then what we can do is we look a little bit further below. We have where we can set the attack, decay, sustain, and release times. Okay, and I believe these are in milliseconds. So that's how they get set. This might not be the best place for me to put it, but I'm just going to put it here for now, just for the sake of time. So if I go envelope 1, set attack. Okay, yes, it's called set attack. Okay, and let's just put 2000 here. Okay, so it takes 2 seconds for the sound to actually kind of come into full volume. And then envelope 1, set decay. Decay always kind of confuses me. I'm just going to put it at 500 milliseconds. Envelope 1, set sustain. And then here, I'm just going to put 0.8. The sustain is normally a value between 0 and 1. Okay, and then envelope 1, set release. And then I'm just going to I'll put that in another 2000 milliseconds. So what this does is this gives us a little bit of control over the sound itself. And then at a later point, we can actually map this to dials to our GUI, and that we can actually control these values. Okay, so now we just need to change. We need to change our code a little bit down here so we can actually route the sound into the envelope. Okay, so now what I'll do is I'll just set up I'll set up a variable called the sound. And then what I can say is envelope1.adsr. I'm not going to wait for forever for the autocomplete to come up, so I'm just going to go ahead and type in the wave. And then I'm going to put envelope1.trigger. Okay, envelope1.trigger, just once again, is that 1 or 0 value that defines whether the key is being pressed or whether it's been released. Okay, so now I've got, I think I'll put level down here. Okay, just so it's, I don't know, I just think that's the way to do it. I can't really explain why at the moment. And then here we're going to change this to the sound. Okay. I don't think it actually matters whether you put level here or level just affecting the wave itself. So I think that's everything. Okay, I think that's fine. Okay, so let's go ahead and give that a try now. Okay. So succeeded. That's a great start. Hopefully this doesn't blow our ears out, because that would be bad. Okay, here we go. We're going to test it out now. Great. So you can hear that it takes a little bit of time, that the attack isn't right away. And then when I release the key, it also takes a little bit of time to actually fade off. So you can see that the envelope is actually working there. Okay, so let's just try this. I haven't tried this yet, so I'm not sure if this is going to actually work, and I fear that I'm going to have to start this tutorial again. But I'm going to go ahead and take a risk here, and I'm going to try a maxi filter here. So let's just try to add a filter here real quick, see if that works. So then what we have is, I could just say double filtered sound equals filter 1 dot, let's see if anything comes up. Okay, so here are some of our options here. I'm just going to put filter, I'm going to use these arguments here. So double input, so I could put the sound as the input. Okay, we'll put, for the cutoff, we could just put like maybe 200 hertz as our cutoff. Resonance, I'll just put at 0.1, so not really much resonance. And then let's just try putting this into our output buffer. Okay, and let's just see what happens. Okay. And then we'll just add our plugin here. Okay, put our outputs up. I actually can't tell if there's any difference or not. Oh, hold on, I hear a problem. Wherever I press the key, it's playing the same frequency, so that's a problem. Because I have it at 440. Okay, that's a problem. So we can just take that out. And then up here we have the this variable that we set up earlier, frequency. And then that's just connected to our MIDI note number. So we did that last tutorial. So there we go. So we can do that. I'm going to set this a little bit lower. Let me say 100 hertz maybe. So we should be able to hear definitely if the sound is filtered or not. Okay, and here we go. Then just add this again. Okay. Connecting. I'm not sure if you can actually even hear that or not. Sorry about that. Got kind of a different setup going on here. So where's my sound card? 1 second here. Sorry about this, people. I can't remember where the sound. Oh, it's here in audio output. So let's go into the Thunderbolt. Okay, now we can hear it. So that sounds quite musical to me. So I don't know if it's filtering though. Sounds like it is. Maybe if I just put it really low, like maybe if I put it down to like 40 hertz. Or maybe it's not in hertz. Maybe it's actually a floating point value or something. I'll have to take a look if this isn't working properly. Okay, so let's just try this. I don't know. Let's just have a look at the CPP again for low res. So let's just look at low res real quick. Okay, cutoff. Let's see what we have for cutoff. If cutoff is less than 10, cutoff. So I think I'm pretty sure that it's working because I'm not hearing as much of the sound. I should probably use something with some harmonic content. Actually, that's probably the problem. So let me just try that quick before we go. So let's just change this, and you can see how quickly like this really kind of this really kind of stands up. You know, I think it's Sol. There we go. So now that we have some harmonics, we should definitely be able to hear some filtering. If not, I might have to just leave it for the next tutorial. So here we go. So let's just try this one more time. Okay, just put this down here. Yeah. So it's definitely so it is definitely filtering there. Okay, so we can just confirm that that's working. So I hope that that's been helpful for you. And any questions about the way that I've done that? I know that I went through some of the Maximilian code quite quickly. Like I said, you know, I've got some experience with Maximilian, so I've been through this documentation before a bit. But any sort of questions that you might have, or anything that's been unclear in terms of the way that I've done that, or why I've done it the way I have, feel free to leave me a comment below and ask, or drop me a line, or join the Telegram group and you can ask any of us there. But for now, that's where I'm going to finish off. For the next tutorial, what we're going to do is we're actually going to start looking at setting up some of the GUI controls. So we're going to look in the plugin editor, where we're going to be able to actually set up some knobs and dials and sliders, and then use those sliders, connect them to some variables here in our filter and in our envelope, and then start actually building up a GUI where we're actually able to control the parameters and make more sounds. So I hope you enjoyed this tutorial, and until then, I will see you next time.